Alright, CNT120, we're continuing on our Chapter 2. We're working on the pieces of our commercial cabling infrastructure. So we talked about the entrance facility, the main closet, if you will, the intermediate closet, if you will, MDF and IDF. Now we'll talk different types of wiring. We have backbone wiring, horizontal wiring. So let's take a look at the backbone wiring. The backbone wire is your cables or wireless links that provide connection between the entrance facility and MDF and between the MDF and IDF. So in other words, I like to say typically between your closets. That's kind of like a generic, and that's why I put quotes around it. And it's also typically between switches. Again, that's kind of generic, but it's really the connections between your major devices, between your major closets. That is typically your backbone links. Many times it is actually fiber optic links, especially if it's in a building. So if I start looking at maps or plans of a building, I started big here. Here is maybe a couple buildings in a commercial facility, a couple nearby buildings. This would be the fiber links between them. Those fiber links between them would be your backbone connections. Okay. If I have a multi-floor building, the connections between my closets are probably going to be fiber. Those are going to be your backbone connections. Again, multi-floor building, the connections between the closets here, more likely than not fiber links, those are your backbone connections. And really, they're going to go from switch to switch kind of thing. That's what's going to happen. Here's another multi-floor building, same thing. In this case, they're green wires over here, but the connections between my closets right here is backbone wiring. Another slang term they use is vertical cabling, because as you look, they're vertically going between your closets, as opposed to the cabling going this way across the floor horizontally. Okay, so there's your backbone cabling. And my other drawing here, the one I did, here's showing you the backbone cabling going between my switches. That orange cable, that fiber cable, that backbone cable between my switches. And here is actually some examples of some backbone cabling, some fiber cabling going between closets. And literally in a multi-floor building, there is a hole drilled through the floor, a metal sleeve put through, the cables go through. Here's actually fiber interduct. It's a plastic hose, almost reminds you of a swimming pool hose, that the fiber cables go down through. That hose is there for protection and a guide. And then after all this goes down through this conduit, this sleeve between the floors, you have fire retardant clay, for lack of a better description, that goes in here. It's called fire stop. Okay, there is your backbone cabling between your floors. So there it is right there. Those sleeves to the floor, fiber cables going between closet. That is your backbone cabling. Again, more times than not, fiber optic cabling connecting your closets together. Fiber for distance and bandwidth. Distance and bandwidth. The other type of cabling we have in a building is horizontal cabling. Well, horizontal cabling, this is the cabling that is going to connect the workstations to your data closet, or the workstations, the user workstations, to the switches in the data closet. That's your horizontal cabling. That is typically going to be copper, UTP, unshielded twisted pair, copper cabling going from the user workstation into the closet. The maximum allowable distance for horizontal cabling is 100 meters. That's the maximum distance that your signal is going to go on a piece of copper cable. And what it really breaks down to, and you have to kind of read a little bit to pick this up, but it gives you a 90-meter cable run and 10 meters of patch cables that you're allowed to use. Well, 90 plus 10 is your 100 meters max. Okay, so if I start looking, here is my closet, and it's the horizontal cabling here, the stuff that goes above the ceiling, down the hall, down the wall into a data outlet. Okay, here is, I have a couple pictures here. Here's horizontal cabling here. It's this blue, it's copper cabling. It goes up the wall, above the ceiling, down the wall to a data outlet that the users can plug into. Okay. Here it is again. In this case, it's red. Comes out of the closet, above the ceiling. Once it gets near where it needs to, down the wall into an outlet that the user's computer can plug into. That is your horizontal cabling. And the max distance we can go from the closet here out to the box is 90 meters. And that still allows me 10 meters of patch cable that I can use on a couple meters here and a couple meters here for things to plug in on each end of that cable run. And here it is more descriptive, going from my patch panel, horizontal cabling out to the outlet box. That's allowed 90 meters, and that gives me a couple meters I can use on this end for a patch cable, and a couple meters I can use on this end for a patch cable. That's what those numbers really mean. Well, my horizontal cabling, they showed you a picture in the book here, that gives me the 90 meters that I can go from my outlet to the patch panel. And that horizontal cabling is typically going to look like this. Bundles of copper cable that are bundled together, sported in data trays going down the hallway, typically above the ceiling. And that cabling, okay, it's going to start in the data closet, terminated to a patch panel. Well, here's a patch panel. The patch panel, as we talked earlier about electrical wiring in house, you could almost think as the patch panel almost as like the circuit breaker box in the house. All the electrical wiring in the house leaves that circuit breaker box and goes to outlets in the house. All my data wiring leaves my closet from the patch panel out to the data outlets scattered all over the floor. So this patch panel is that point where all the data cabling comes to, and it's organized and numbered so I know where all these data ports are. So my horizontal cabling leaves the closet after it's attached to the back of the patch panel. I'm showing you the back of the patch panel here. The wires get punched into it. Okay, it's going to leave the back of the patch panel. It's going to, and here's my patch panel in the closet, it'll leave there and above the ceiling and down the halls. Okay, so it's going to leave the back of the patch panel bundled up the rack, up above the rack into these trays, down the hallway in these trays, supported. And again, these trays are normally above the ceiling. You don't see them. Above the ceiling in these trays, down the hall. And then eventually it comes down the wall and it gets terminated at some kind of outlet box on the wall here, on one of these walls here, and right near where the user needs to work. Okay, right where the user needs to work. That is where my horizontal cabling gets terminated. It's going to get terminated at the patch panel in the closet, travel above the ceiling till it gets near the work area, down the wall into one of these data outlet boxes. Something like one of these there that the user can plug and unplug in. Okay? That's your horizontal cabling. Last but not least on our pieces of our wired infrastructure is my work area. The work area is just that. This is where the user is sitting and working. So it's going to encompass the workstations, the printers, the IP phones, the stuff that's going to be around a user's desk. This includes other things along with that, including patch cables, wall jacks, outlet boxes, those kind of things. All that stuff necessary to connect the user back to the closet. So my work area, I have near my desk, I'm going to have an outlet box on the wall and things like that. This part right here, here's my computer and all that jazz. I'll have the outlet box on the wall that my computer can plug into. It's this part right here. Here's my computer, patch cable, outlet box on the wall. Okay. This right here, outlet box and things in my work area right there. It's that piece, okay, this data jack on the wall, and it's at my work area here where I have my computer and printer and things like that. And it'll be the data outlet that I'm plugging into, one of these guys, and chances are it's either going to be on the wall or down at the bottom of a cubicle kind of thing. Okay, may not look pretty, but it'll get the job done. It should look better than this, but you know that the idea is it's this connection for the user to plug into, and it has actually a faceplate on the wall with an outlet jack that's in there, snapped into, and the wiring is terminated in here. Okay, the horizontal cabling is terminated into that. So the user end of the horizontal cable is terminated into this outlet jack right here. It gets punched in. Okay, there is a color code to it, so it goes in the correct order. You'll notice that the wires are all organized in there. It has to go in the correct order so the data gets is passed across there. Okay, those are the big pieces of my cable infrastructure. Along your chapter, you read a bunch of smaller things as you were going here. So I'm going to go back and pick up the smaller things now. I hit the big pieces first, now I'll pick up these smaller pieces. In my system, I'm going to have racks. I'm going to have equipment racks. All my equipment in a closet needs to bolt into these. And these are there to basically house all my equipment. They're standard 19-inch wide frames. They do make larger ones, but they're standard 19-inch wide frames. They'll typically be mounted to the floor. They can also be mounted to the ceiling or wall, too. The racks themselves are measured in rack units, or U's, and that describes the number of pieces of equipment that can bolt into it. They come in 2 and 4 post racks. 2 are fairly standard for just routers and switches. 4 post racks are there and give you additional support for things like rack mount servers. Okay, so I could have one or the other style in a closet. Your main closet is most likely going to have 4 posts. Your intermediates might just have 2 posts because you might not have anything other than routers and switches. Okay, that is not uncommon to have happen. They can be ceiling mounted or they can even be wall mounted. They don't have to be large, just enough to get the job done. They are measured in U's, and a U is basically a 1 unit, 1 router, or 1 switch that's going to bolt in. Well, here is a 1U router. Here's a 2U router. 1U is basically, you know, the thickness of a thick book, if you will. That is 1U of a rack. A 2U would be the size, you know, like a big old dictionary sitting on your desk, 2U high. And the racks are indicated on how many U's can fit in there, how many pieces of equipment can fit in there. And that's what they're getting at here. A rack would be so many U's, and my pieces of equipment are all different sizes, so that lets me know how much can actually fit in there. And when you buy them, they'll even tell you available 24U to 58U. They're giving you a unit size, how many things can be bolted in. And here's a whole bunch of different rack sizes just to give you an idea. There is even programs out there, drawing programs, to allow you to draw out your rack to make sure everything will fit. So when you go to put it in your closet, everything actually does fit in. Everything bolts in that you want it to fit. On my rack, I also need to think, if I have multiple rows of racks in a closet, I need to think about air moving through there. There is actually a cold side of the rack and a hot side of the rack, and it works in this manner. In a main data closet, I probably have ventilation coming up through the floor, so one side of my rack needs to be pulling in the cool air, and the fans in the back should be blowing out the hot air. So as I line them up, I'll have a cool side where cool air is coming in and then hot air going out. That's a typical arrangement if you have rows and rows of data racks, okay, especially if it's a server closet kind of deal. Okay, so there's your racks or rack systems. Also in my closet I have patch panels. Well, I briefly mentioned that, so we'll touch on that again. Your patch panel is that panel of data receptors, outlet jacks, that all the horizontal cabling gets terminated to. And the purpose of that, as we said before, just like your circuit breaker box in your house, all the electrical wiring goes to the circuit breaker box to organize it, label it, so you can turn on and off outlets individually, if you will. Well, all the data wiring comes to my closet, so I need a way to take all those data wires coming in and organize them. Well, all those data wires get brought into the closet and terminated into my patch panel. That way they're all organized, and I can find a particular data port. Well, patch panels come in sizes, 24, 48, 96 ports, and those usually coincide to switches. Most switches are 24 or 48 port switches, so I could put a 24 port patch panel in to connect to a 24 port switch, 48 port patch panel to connect to a 48 port switch, and so forth. That's why they come on multiple sides. Here's the front and back. The front is the RJ45 ports, all labeled and numbered. So all my data outlets coming in from a particular computer lab could come into these ports here, and I can label them 1 to 12. Out in my computer lab, I can label all the ports on the wall 1 to 12, and then I'll know which port is which. The back is this side here. These are rows of 110 blocks that my horizontal wiring gets punched into. They get laid into there in a color code order, and I punch them in to terminate them. And I have a mechanical and electrical connection by doing that. Like this. Here's my horizontal cabling coming in. I lay it in a color code order, lay the wires in, use a punch down tool and punch them in. And this holds it physically, as well as there's electrical contacts in there, a little metal V that the wire gets forced into to make electrical contact. And that patch panel is there that, again, my horizontal cabling is terminated at the back, and I can use a patch cable to connect up to a switch up here. Okay, that's why that is there, so I can connect and disconnect to different switches as I need. Plug this in, unplug this port, plug this port in, unplug that port, and so forth. Okay. When we come back in the next one, we'll continue on the last couple pieces here.